In this work, we present a novel method that allows designers to easily direct user attention via visual flow on web designs. To communicate information clearly and quickly, an effective web design should direct users' attention through the important components on the page along a specific path. By moving their eyes along this path, users will have higher chance of performing the actions that designers want them to do. However, directing user attention effectively on web designs is a daunting task, requiring deep understanding of complex user attention behaviors under different configurations, and a lot of manual efforts to explore a large design space before getting a satisfying design. We present a novel method, which allows designers to easily create a visual flow to guide users through a web design. Given an input web design, our method begins by automatically segmenting the design into a group of disjoint page components. Then, a designer draws a path over a subset of the components to represent the attention path that users are expected to follow. Finally, our method will automatically refine the input design by changing the appearance and spatial properties of the page components. The result is a new design that can effectively direct user attention along the input path. To understand and model user attention behaviors on web designs, we collect a set of web designs of different types. For each web design, we use an eye tracking device to record the eye movements of multiple users on it under task-driven conditions. Given the eye gaze data on our web design collection, we learn two user attention models. First, we learn an attention transition model, which predicts the probability of user attention moving from one component to another. Second, we learn an attention order model, which predicts the probability of one component being visited before another. Using the user attention models, we optimize the input web design by minimizing an objective function comprising three terms. The attention term encourages user attention predicted by our models to follow the input path in the optimized design. The prior term encourages the optimized design to respect commonly used visual design guidelines, such as alignment, balance and spacing. The regularization term prevents the optimized design from deviating too much from the original design, thus preserving the original layout style of the input web design. We now show some results generated by our method. On the left, we show the input web design and input reading path. On the right, we show the results generated by our method. In this example, the first component is moved to be closer to the second component, to encourage users to move their eyes from the first to the second component. Meanwhile, the group of links is changed to have a darker color, to reduce the possible transition to the links from the first component. Furthermore, the second component is changed to have the same color to the third component, so that user can naturally move from the second to the third component. In this example, to make user attention move from the first component to the second component, the set of components on the top of the design are moved farther to the right, and the components below the first components are set smaller. This will suppress user attention transition to these components from the first component. The third component is set to have a bright color, which will draw user attention to it from the second component. The color of the fourth component is changed to be the same as the third component, so that users can perceptually group them together and thus move from the third component to the fourth one with higher probability. Also, the three icons below the fourth component become smaller, reducing the chance of users directly moving their eyes to the icons from the third component. We show more examples, and highlight the main changed components using red rectangles. Please see more results in our paper and supplementary material.